David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Let's do a lesson on graphing quadratics. And we're going to focus first on how you do that using your graphing display calculator. Okay, so it's a very powerful tool, but you can still lose points with the correct graph in your calculator if you don't communicate the essential information over on your sketch. So here's the requirements for that. Sketches based on graphing display calculator, GDC, must include accurate overall shape. So this is what that A letter determines. Is it a narrow parabola? Is it a big wide parabola? Make sure that the vertex curves. Don't make a V-rabola. You want to make sure that that shape is accurate for the points and for the function that you have. Then you want to make sure that you note the x-intercepts and the y-intercepts. And if you remember, this can have 0, 1, or 2 x-intercepts. Always has 1 y-intercept. So you should show those on your axes, note those points, and it should be roughly accurate. It doesn't have to be super precise, but it has to be roughly accurate. Then you want to show the axis of symmetry. Remember, this is an equation for a vertical line that goes through the vertex in the form of x equals some constant. So you want to show that on your graph. And then finally, you want to show the vertex, the turning point, which is either a minimum or a maximum, and show the coordinates of that point, which is why I put label these. All these things should have labels, not just dots. Okay, first task. We're going to graph this quadratic function, this parabola. I want you to pause the video, get out your graphing display calculator, and put this graph in there. All right? Now I want you to find all the key points. Find the vertex, and then find the x and y intercepts, and find and write down the equation for the axis of symmetry. Okay, now that you've got all that, I want you to prepare a sketch on your notes. So keep your calculator display open and go ahead and sketch that parabola onto your notes. Here's what I get. Notice how my intercepts are all labeled. My vertex is labeled, my axis of symmetry equation is labeled there. So go ahead and pause the video and work yours if you messed up. Otherwise, next one is I want you to say the domain and range of this function. So domain, what's that? And the range. Pause the video and do your best there. Okay, I get my domain without restriction. We can go negative to positive infinity with my x values, and you can see that pretty much right there with my parabola. My range, certainly I can go down to negative infinity, but I'm never going to get higher than my maximum, which is 10.125, which is the y-coordinate of my vertex. Let's talk about vertex form. This is a nice, handy equation form that allows you to graph quickly and easily. This discussion is for how to graph a quadratic, a parabola, without your calculator. And that's the power of this function. Now you can put it in there and it will graph it just fine, but you should be able to use this equation form to quickly and easily create a graph without your calculator. Okay, so let's take a look at it. It's f of x equals a times x minus h squared plus k. And we looked at this before. Our a factor is a compression or a dilation. Our h is our horizontal translation, moves the vertex, and our k is a vertical translation, up or down. Our vertex is given by hk, and our axis of symmetry is x equals h. So this is going to give us almost everything we need to make a graph of our parabola. All right, here's one. Pause the video and make a hand graph. Don't use your calculator. Make a hand graph of that parabola. All right, let's see how you did. Before I even started my graph, I took a good look at my equation and I noticed a few things. It opens up, okay? No negative here. It's going to be compressed. This number is bigger than 1. So it's going to squeeze my graph down. My vertex is going to be at the point -1, -4. So I've translated the parabola over 1 unit to the left and 4 units down. So now I know how to create my axes so that I can capture my graph, and I know how to scale my axes because I have a feeling for how big and small my numbers are going to be. So then I just put in my -1, -4, and then I use the trick that I know. The mother parabola goes over 1, up 1, but we've got a 2 out there. So we're going to go over 1, up 2. So that got me these 2 points. So moving from -1, 4, I got -2, -2 for that one, and 0, 2 for that one. And guess what? I got my y-intercept just by looking out there. And then I did the same for these 2 points. But instead of going over 2 and up 4, I went over 2 and up 8 to get this next set of points. Sketched my graph in there, labeled my points, put on my my symmetry axis, x equals -1. There you go. All right, let's see how you did. So first off, I noticed that my vertex is at the point 2, 5. Change the sign, keep the sign. 2, 5. My axis of symmetry is x equals 1/2. So I went ahead and put my vertex and my axis of symmetry on there. My a term, -1/2, tells me that it opens down and it's going to be dilated wider. Not compressed, but it's going to be dilated in an open direction. It's going to be wider than the standard mother parabola. Okay, so now that I had all that, it gave me a good idea about how to sketch my graph. I knew my vertex was here and it was going to open down, so I gave myself more room over here for my graph. I put my vertex on, and now I'm going to use my A, what I know, so I can get my next points. So I'm at 2, 5. I'm going to go over 1 to the right, and I should, instead of going down 1, I'm going to go down 1/2. So my next point is 3, 4.5. And then my next point, I'm going to go over 2, so that's from 2 to 4, and I'm going to go down, not 4, what I would normally do, I'm just going to go down 2. So my next point is 4, 3. Now, if I want to use my reflection, I can reflect these 2 points right across the axis of symmetry. I don't have to think so hard about these 2 points. So this one's going to reflect there, and then the 4, 3 is going to reflect to 0, 3. I have 5 points, sketch in my parabola. There you go. One last parabola. Check it out. f of x equals -3 times x minus 1 squared minus 6. Pause the video, write down the attributes of this function, make a graph, come back. Alrighty, let's see how you did. So here's my summary from vertex form. My vertex is 1, -6. My A is -3, which means it opens down and it's compressed. It's a narrower shape. Finally, my axis is x equals 1, which runs right down the middle like that. Finding my points. First thing I did is I put my vertex, 1, -6. Now I got my next 2 points by going over 1, but instead of down 1, I'm going to multiply it by 3. So I'm going to go over 1, down 3. So that's going to give me the point 2, -9, and the point 0, -9. Now my graph won't fit the next point. It's so far down there. But I want you to pause the video and calculate that point and come back. What I get is that next point is going to be 3 -18. Normally, you would be 4 down. When you went 2 over, you'd be 4 down. But we're multiplying it by 3. So instead of 4 down, we're going 12 down. So 12 down from 6 down is going to be 18. So that's why we have 3 -18 for that point, but we can't fit that one on our graph. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.